Artificial intelligence and machine learning sound kind of mysterious and ominous. Big data sounds even worse. But big data and machine learning are a delightfully matched couple, with strengths and weaknesses that complement each other beautifully. Data is the source of the intelligence in artificial intelligence. If you want more intelligence, you need more data, and nothing has more data than big data. Big data is not just a big database, it's not really a database at all. This is a database. A database has focus. You decide to include some things and exclude others. This is a database of hockey players, so we exclude baseball players, pro cyclists, and sumo wrestlers. It's organized. Everything is in its place. When you put stuff in a database, you're recording identification, descriptions, and measurements. This player is named Guy Lafleur. He shoots right. He is 6 feet tall. This is his record. Once the records are in, we can use the database to classify, associate, order, and count. Classify. This is a goalie. Associate. These players are on this team. Order. These players scored the most goals. Count. How many goalies play for the New York Islanders? Find. Where's Bill Flett? I can find Bill Flett using association and identification. I can locate anything that's in a database because records can only be in one place, and there's only one of them. Databases can also ensure we don't have duplicates. If I have a duplicate card for Bill Flett, I can't put it in the database without removing the one that's already there. There's no room for additional Bill Fletts. The database holds identification, description, and measurement so that I can classify, associate, order, count, and find. That's the business of a database. It's a good business, but it's not big data. This is big data. Some parts of it might be organized, others not so much. If you want to group parts of the data, you can, but you don't need to. There's very little decision making. Big data just takes everything. It can take baseball cards, it can take sumo wrestlers, it can take a bunch of wine corks. It can also take this set of meticulously organized hockey cards. And yes, it can even take 3 Bill Fletts. It can take all of this stuff every day, and it can keep it forever. Now, I said that with a database you can count, order, classify, associate. You can do all that with big data too. You can also have machine learning do those things for you. Machine learning can figure out who is on what team, whether a player shoots right or left. Not with rules or assumptions, but with data. You show it enough pictures with a label provided, and it will soon be able to guess accurately. With enough training data, you can find the patterns in the data that enable insights. If you show it enough different pictures of Guy Lafleur, it can recognize a picture of Guy Lafleur that it has never seen before. This is why you need so much data. Lots of pictures of Guy Lafleur, and even more pictures of not Guy Lafleur. One of the challenges in this line of work is that you need to ingest and prepare a huge amount of highly variable data in order for it to be used for machine learning. How do you ingest 500 Corks? And what sort of machine learning model could you train with them? To prepare data for machine learning, it has to be filtered, organized, standardized, and possibly labeled. We could then use the Corks to train a model that would predict the color, country, region, and price of the wine. That sounds like a job for artificial frost. But we'll definitely need more wine. Data. Data, I mean. Not, did I say wine? Oh.